All right, let's begin. Welcome back to the series from Breadboard to Market. Thank you for checking us out. If you like what you're seeing, please like and subscribe. Hit that bell notification to be informed of any new video uploads to the YouTube. So the last stream, the last video, we went ahead and did as much verification to our PCB layout as we could within KiCad, just by looking at the design rules, by running the design rule check, fixing any issues, ignoring some such as courtyard overlap, things that we can't immediately set rules to ignore, which is fine. And then like distance between pads in the footprint, there's nothing we can do about it. That's the way the parts are designed. That's their designated pad spacing and size. We just have to just ignore those rules and be okay with it, and it's fine. So we did as much verification as we could here. Then we exported the manufacturing files into Gerber and drill files. And now what we're going to do is we're going to pull those into a Gerber file viewer and verify. Now, KiCad has their own Gerber viewer right here. But as a general rule, you're better off not trusting the same tool that you use to generate the files. Don't trust it to validate the files. You want basically a third opinion, a third-party opinion. Basically what we're going to do is we're going to be using a program called Zoff's PCB. It's a Gerber viewer. It does a lot more. It really does. It's a very powerful application. There's a free license available, which is suitable for general evaluation work, just to make sure your Gerbers look good enough to be manufactured. So I'll have this link in the resources markdown file. You could get it. It's just a simple registration for the free version. They want your email address, but who doesn't anymore? You'll get a free 30-day trial to the advanced features, and then after that, it'll go to the standard free version, which will suffice. We're just looking at the Gerber files, trying to make sure that there were no mistakes made between when what you see here and what KiCad generates for the Gerber files, the output files. We want to make sure there's no mistakes and everything looks just fine. So I went ahead and got Zoff's PCB running, open up. Now, I think I'm going to grab all that, and then I'm going to just, basically Control A, then use a Control key to kind of ignore all that. It's a Gerber job file. Now, I think it's been a while since I've used Zoff's. I used another program called GerbView, but I don't know I can't remember if it's free. So no, dragging and dropping does not fix that. Does not allow you to do it. So we're going to do File, Import, any format. Okay, so it looks like that wants to open manual file import. Okay, here we go. Okay. We don't need those. Control A and click, and that's the Gerber job. The rest of these should be fine. We're gonna add items. Layer stack. We're just kind of ignoring this. Some of these done. All right. Why are you upset with me? Like I said, I haven't used this because it can be a little bit of a add items. is it? We have to bring these guys down here. The drill plates. All right. That might be why that was upset, because we had to drag the drill plates down. Missing cores. Pre-peg on the stack up. Let's just continue. I don't really care about a fancy rendering. Okay. Oh, come on. Why can't people make tools that are easy to use? I don't want to rotate. God, it's just give me... Oh, wow. Okay, what an official pain in the butt. I'm sorry. Powerful software, but it's honestly a pain in the rear. I don't need all this fancy stuff. I just want to look at the Gerber files. View. Let's see if we can just have it. Camera orthogonal. All right. Yeah. Boom. So I have to Alt and right click to drag around. All right. Okay. All right. Jesus Christ. So copper 1. All right. All right. No zoom. I don't care. Reset. I'm gonna put everything back here so we can see it. All right. Zoom. So copper 1 is your top layer. What in the world? Don't put... Oh my God. All right. I don't really care for all this fanciness. Okay. All we want to do is to be able to just render the layers and take a look at them. Stack up. See, because now I have to play a big game to try to figure all this out. Yeah, let me see here. Let me move that real quick and do a search on this side real quick. Because, you know, I may not recommend a trial. Let's see. Yeah, see, here's the problem. You can only get a trial or GURB view. I think that's why I went to GURB view rather than sticking with Zoffs. Stop doing that. I don't want to peel. I want to stay at zooming. Wow. Don't change it on me, you stupid program. Ugh. All right. All right. So that's the top layer. Okay, so I can't reorganize. I can't move around. Okay, those I don't care about. Those are those. I can't tell what that is. That looks like one of the internal plane layers. That's a signal layer. That's a signal layer. That's another plane layer. That is top overlay. So now we have to play. Reset. Okay, copper. Wow. So copper 1. Can I actually rename it? And then copper 9. Silk screen. Okay. All right. Oh, wait a minute here. Front silk screen. All right. Let's see if that works. Copper. Internal. 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 Kind of keep that. Bottom overlay. Keep that all the way at the top. That's edge cuts. That's your. These are the user. So top. Bottom. Front copper. Okay, so silk screen, front silk screen, front page, front mask, front copper. Mask, okay. All right, okay. Let's read and render that. All right. So it should have rearranged all this. I'm going to be honest with you guys. This is giving me an absolute headache. This software is not user friendly. It is not. It's almost too advanced for what we actually need it for. Okay. GurvView. Okay. This is how much nicer GurvView is. Drag, drop. Boom, here we go. Here's all the layers. Oh my God. All right. Here's all this. Let's see here. User 1 and 2. We can move those down. See here, we can just pop them down out of the way. I'll really do that little preview down there. User 2. All right. So we'll just leave it in GurvView. I'm just going to go ahead, file. We're going to save the project. File, project, save project. Nope. That's different. Project I'm working on. Let's just grab that. We're not going to save it as that Gerber. We're going to say, review. Yeah. I mean, honestly, if you want to take the time to learn Zoft's PCB, please be my guest. Otherwise, license for GurvView. You get a free trial. I think it's about 30 days. License about $85. I'm not encouraging anyone to pay for anything. This is extremely frustrating, and I'm not going to spend time trying to learn a software package that's too advanced for what we are trying to do. This program makes it so much easier to set up and move. Edge cuts. So we can have properties. I'm going to change that to red, dark red. Okay. Okay, front. Okay, these are our drills. I'll bring them all the way way up to the top. These are the plated through holes and the non-plated through hole drill files. All right, edge cuts, that's basically your board outline. Okay, front copper, let's go and move that up. Front mask is your solder mask. So we're going to put on top of the copper. Front paste. We're going to set it on top of the mask. I'll explain how all that works here in a bit. Front silk screen, that we'll put all the way up here. Inner layer 1, 2, 3, 4. That's your plane, signal plane. We'll put, let's see here. We want to kind of mimic it. I'll show you why here in a minute, why we're going to match the bottom to the top. So here's your copper with the mask on top of it. Bottom silk screen. Whoops, let's go down. Let's put it right there. And bottom paste right underneath the silk screen. So we're going to turn this off for now. Leave the edge cuts, it doesn't hurt anything. Silk screen. Real fast. Because this makes more sense when you actually see it like this. So since solder paste is gray, like a silvery gray, we're going to make this a silvery gray color. Solder mask, since we're going to go green. Let's just choose, well, yeah, let's just choose that green. No, let's go with the lighter green. The hopes is copper. So KiCad. Front copper is red. The reason I match it, it's easier to understand what you're trying to do when it can match as closely as possible to your editing tools. Inner layer. So that's like a light green, brown. So like be like a light, kind of like a sick green, maybe like a lime green. That one is like a brown. Yeah, not exactly close, but it's close enough that you'll get the gist of it. That layer, like a robin egg blue or something. And then that, like a violet kind of color. Yeah, that should be close enough. Bottom silk screen. So it's just going to be white. Bottom paste, again, the silvery gray. Solder mask, we're going to, same green color. Bottom copper, a blue. Now, save the project. Okay, so there's a whole reason for this. So we're going to go and reactivate the drill files, the drills. They're white in here, so let's just give them an outlandish color because I don't want them blending in. I want them to contrast so we don't think that they're like silk screen. All right, so the main objective, so what we're going to do, we're going to leave the drills there. We're just going to, we're going to be focused on the top layer right now. And make sure the drills are still here. All right, so that's our silk screen. This is a better representation to how it's going to look when you actually get the boards in hand. Again, I don't trust the tool that created the Gerber files to actually validate the Gerber files. That's just a general rule you want to avoid. So we're looking at, right now, we're really focusing on the silk screen. Just kind of, look at it, get an idea, make sure it doesn't overlap anything it shouldn't. Things look clear enough, organized enough. Because again, now is the time to catch mistakes and make adjustments, re-export your files, and then recheck. Now is the time to do that before you spend any money. Before you put any money on. This is all, this is the time to do it. So 3 volts, 5 volts, okay. Status LED, debug or boot enables. Nothing's jumping out at me on the front silk screen, so let's go ahead and hide that. Now, we're going to be looking at the paste, the solder mask, and the top layer copper. So the paste, obviously, that's the gray. You want to make sure that any SMT part has solder paste applied to it. You don't want like your fiducials to have solder paste on them. They're supposed to stay clear. You don't want through hole pads like these test points to have solder paste on them. Anywhere, pretty much anywhere an SMT pad is going to go. Because a common thing you'll have happen, especially when you import footprints, is sometimes the paste mask won't be opened up. Sometimes it's opposite, the solder mask won't be opened up. So for the paste mask, just assume that these gray splotches are where the actual solder paste is going to be applied to the part. So when you get the stencil, it'll be basically a flat sheet of metal. So think of it like a, like a really thin sheet metal. And these are going to be laser cut openings. And that's where the paste is going to be placed. For those who've never really worked with PCB stencils, I'll get images and video when we actually go to build. Because like I said, I have a webcam and we're gonna do some actual video of the process and stuff, so you know what's all involved. We're gonna be hand assembling. You'll at least understand it. So you want to make sure that any SMT part is actually pasted, and now you also want to hide this and look at your solder mask. Now this is opposite. So for your solder mask, you can kind of think of it, these are the holes that are cut into it. Think as a film that's going to be applied to this, applied to the board, and these are the openings. So you want to make sure that the openings are where your parts are. And then they line up, your pad, your openings, and the paste, they line up. You can stack them together. That's basically what you're looking for. And that your through-hole parts don't get pasted, but they're still opened up because they're going to be plated through-hole. They're actually pads that you can solder to. So like this will be a solder pad that you run the through-hole part to and actually solder to. So you want to make sure the solder mask is open around that. Now the yellow, again, is your drill. So that's a hole punched through the board. So you want to make sure everything's open, you can see everything, and everything's fine. So that's good, that's good. Now we're going to look at the copper layers. We want to make sure that when KiCad generated the Gerber files, that it didn't accidentally encroach any plane or any copper pour onto a pad it wasn't supposed to, that there's no stray lines, no stray connections, no stubs. That nothing got mixed. So it's just a really cursory review of how the Gerber file was generated. It's going to be more of a testament to how it's going to be manufactured in the long run by the vendor house, by the PCB house. So there's a fiducial right there. Again, we can go here, make sure the mask is open for it. Yep. So yep, we can do that. Make sure those are through-hole pads right there. You can tell by the drill marks. Those are vias. Everything looks good. For really complex or high density boards, a check can take quite a bit of time. But for general, you just want to make sure that nothing's shorted out. you don't have any erroneous copper that left behind. All right, so that's our front copper. Now, what we can do is we can leave the front copper. So this is our internal plane layer. So if we go back, internal plane layer is here, and what's that tied to? That is I think that's 3.3 volts. Let's go here. So that's a power plane. Let's go here. Zones. Let's go to 3.3. Okay, so that's your 3.3 volts. So basically, what you're looking at is this is your 3.3 volt lane plane. Let's see if we can find something that's actually supposed to be tied to it. So let's hide the copper layer. It's kind of hard to tell. All right, so right here. So you've got your drills. Okay, so you've got a thermal relief right there. And I don't want thermal release. I actually want... Well, I mean, thermal's fine for this. I'm okay with thermals for these bigger pads for that. That's fine. That's a through hole. That's a test point. But you'll see like your vias right here that are popped through that are tied straight to 3.3. So the big opening around it means it's not tied. That's basically you're punching a hole through it. Nothing's connected. But right here you see your via drill, but it's actually solid. So you got a via that ties into that. That's what you're looking at here. So you want to kind of just make sure that holes are clear, concise, punch cleanly through. So that's your 3v3 line. This is an inner copper layer, the first signal layer. So in KiCad, this will be this layer right here. Again, you want to make sure that any signal lines aren't touching. You don't have extra copper. You don't have anything encroaching, especially your signals. That you're not accidentally touching a via. You're not shorting anything out. All your teardrops, everything's formed properly. That's all we're looking for. Almost seems to be a waste to throw this extra layer in there for, what, 4 traces? But at the end of the day, if we have to make changes to the board, modifications, whatever, we have the room to throw them on there. Actually, one of the things I want to check for, yeah, okay, so that's that big power bus connecting for the motor chip. Yeah, it's a waste of a signal layer. We might have been able to route them through other layers if we had just taken the time, been more patient. But we have it here in case we want to add to the board. We need to change layout. We want to, fix anything. You're better off having it. And then our ground plane. You see how many more vias are actually tied to this plane than there were to the positive plane, because these are all your ground connections. So right there, nice solid connection there, nice solid connection there. I don't know why it threw thermal reliefs for that one, but not on this one, but I'm not going to argue with it. I'm not going to complain about it. It's fine. It's not going to affect anything. If we have to make a revision to the board layout, we can always fix that later. It's a test point, and all we're just doing is just catching on the 3.3. So again, same thing here. You're making sure that there are no odd anomalies where you're going to get a short on this plane. That everything cuts cleanly through. So that looks good. Now we're going to be looking at the bottom. Let's just go and turn all those on. So we're going to look at the bottom silk screen, at the bottom layer. So remember, everything's on the bottom and it's mirrored. So that is the board part number, basically. That's going to be in the bottom actual copper layer. Notice it's mirrored. So you want to make sure that's readable. That's fine. But we're going to concentrate now on the designators, the silk screen. So nothing looks out of place there. Not too many parts over here. Now let's see if like one designator is rotated out. I'm not going to argue. This is a first run board, first revision, first spin. Chances are we may have to spin it again. Spin one more copy after this, make some revisions. Sometimes you don't. Sometimes you get lucky and your first spin does really good and it's exactly what you want. But don't ever count on that. Never count on that. So the silk screen looks good. So now same thing, paste and solder mask. It's the exact same thing as before. The gray is where your paste is going to be applied. And then your mask is the opening. So kind of just look at your SMT parts. If you want to keep the silk screen on to help figure out what's what, nothing wrong with that. Help designate and keep track of what you're looking at. So all that looks good. The mask, again, your through holes are going to be exposed. So the green means that's where it's going to be removed. So it's basically an opening in the solder mask and basically the film that goes on top. Your through holes are exposed. Your SMT pads are exposed. That looks good. So we're going to look at the copper layer, same principle. We're looking for anything that's too close, shorted out, strays. Because all it takes is one mistake, one problem in Gerber file generation for everything to get thrown all out of whack. Okay, hide that because that was hiding that trace. Nothing looks out of whack. That looks beautiful to me. All right. So I'm going to re-enable all this stuff. Yeah, Zoffs isn't a bad program. It's just got a steeper learning curve, and it's more complicated than what you need for what you're trying to do here. There might be other Gerber file viewers, but I personally like Gerber. It's a good program. I'll put a link to their website into the resources description. Like I said, you get a free trial. Sorry about that. You get a free trial, and then you've got to pay for a license. But I'm not encouraging you to pay for anything you cannot pay for. But it's a great package. And if you intend on doing something like this long term, it's well worth the money. But for a one-off board, something you may not do more than just one, the trial may be more than sufficient, or just learn Zoffs. Again, it's a great software package. It's just the learning curve's too steep, in my opinion. So we're going to save the project. That's done. So I'd say the review is done. Some other stuff I kind of forget to do. Let me drag this back over. So our project. So we're not 100% done with manufacturing file generation or reviewing, because technically the bombs are part of manufacturing file generation. So we're going to continue working down through this stuff, because we're going to be kind of generating and reviewing as we go. So first of all, let's just say we're done with the Gerber review. What we could have done was, so in here, Gerber file review. Could have just done that. And Gerber file review. Could have done that. Should have, the better practices you get into with, project management, using Kanban boards, and other things. It'll come second nature. Again, I have a bad habit of preferring to design and build, and I just rush into it, and I just get ahead of myself and kind of forget about this. It becomes last minute, like, oops, I should be working on that too. So we've done the review. Let's go to our folder. So we have our generated bill of material. So let's go and close the GURB view. We don't need that. Technically, we don't need KiCad, the PCB layout. So let's go and close that. I will open the schematic editor just in case we need to refer to something. So I'm going to open LibreOffice Calc, wherever it decides to open at. Oh, lovely. But hey, we've got an update for you. Let's update when you actually want to use the software. Wonderful. My favorite thing in the entire world. Yeah, and I want to reiterate to anybody who could be listening, especially from, Zoffs, hey, open websites for me. Thank you very much. Wow, I love you guys. Let's copy that. Go file, open. We're gonna open the generated bomb. Automatic, blah, 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 detected, separated by, looks like commas. Let's see. 81 designator. Comma. Well, let's see what this does. See how bad it breaks it. Okay, I do not like you. Oh, it's semicolon. What the world? What in the world? File. I did not expect that. Separated by... Oh. Now let's see what that does. All right, semicolon it is. Okay. All right. KiCad. I do not like the way that looks. That does not give me all the information I want. So, it's a learning experience. Let's go back to KiCad. Let's go back to PCB editor. Wow. Is there a way to materials? No, I don't want to do that. I want to be able to customize my bomb. Oh, this is going to be lots of fun. I wonder if I can do it here. Let's see. Can I do it from the schematics? File. Edit. Tools. Generate bill of materials. All right. Edit. Oh, okay. All right. Don't need the data sheet. Don't need the footprint. Value. Let's see. Reference is a designator. Quantity. Manufacturer. Manufacturer. Do I have something spelled wrong in there? I don't know. All right. Okay, so it says it through here. Now, let's get out of here. Where did you throw it? It's probably right there. All right. Apply. All right. Let's see what that did. Okay. Huh. Rename. Let's copy that. Because you know what? Let's just leave it alone. My head hurts from trying to solve things. File. Open. Open. Okay, detected. Let's try this. Exclude from bomb. Okay. There we go. Reference. Okay. So what we're going to do is we're going to save as, and we're going to save it as an Excel. And we're going to save it. Version 1. All right, so now it's an Excel format, and we can go through and clean it up. All right. Not the cleanest, interesting format, but that's fine. Reference, we're going to go and pull this over here, because that's all test points. Exclude. Well, let's get this column out of here. Delete columns. We're going to save it. Manufacturer 1 part number. Vendor 1A. I don't know how I screwed that up. Vendor 1B. All right. All right. 1A part number, vendor 1A. So this is where I was saying that entering all that stuff will make sense. I don't know why I had that 1A duplicated. I have to look. Maybe I have a space in there somewhere. That's easy to do. So what we can do then is over here we can do notes. Oh boy, I can really spell out the word notes. Test point. Do not place. Actually, no, we're not. We are probably gonna place them. This is for our first revision bomb. So one of the things I wanted to do. Logo 1, and we don't need that here. Delete rows. Mounting holes, don't need that. Delete row. Fiducials, they're not a purchasable item. It's grabbing everything that's actually in the system as an entry. So this will be our Excel. This is, you know, basically LibreOffice, just a spreadsheet. Just call it the spreadsheet version. So some things you can do if you really wanted to do things to get an idea. So what we can do here is PCB. You should always throw your PCB as a bomb item. This off, text. Show you what we're going to do. We're going to grab that. A little bit easier just to grab it from something without trying to type it in. Paste. Okay. And we're going to give it an arbitrary value for low polyvolume, low volume. So we'll give an arbitrary volume for price. Okay. So, show you what we're going to do. One of the reasons I like doing this. Insert column 4. Insert column 4. You know what? Let's rearrange this. You hear a cat. That's my OV extended, low volume extended. So we can play some games here. We can above. Nope. We're just gonna kind of pad a little bit above it, and you'll see why. I know, taking a little extra time, but this comes in handy. So we have our quantity here. Let's see if we can do the equals A, see B times. So that's the extended cost because we're taking our quantity. Does it fill down just like Excel? All right. All right. Now, what we can also do, can we format cells? We're going to do in currency. Okay. So now you get an idea. Oh. Now, here's what we're going to do that's fancy. Per board. My cat Henry. Now this is just going to be a so we want to take the low volume. Let's add a little bit extra. All right. So that is a roughshod estimate at the minimum low volume cost for a board. Now we're going to do per board HV cost. Just because it sounds fun. Oh. Okay, my cat wants to let's see what we can do here. Oh. And vendor 1A cost high volume. Vendor 1A HV extended. Oops. Okay, so what we're going to do is the same principle here. We're going to take that equals quantity times the actual part. And we're going to drag that all the way down. So let's imagine our quantity, at quantity of like 1,000, we're looking at $1. So let's just go ahead and format these cells as currency, make our lives a little bit easier. And then, well, Henry's on my desk. He's trying to be my assistant. Sum of this to here to pad it in case we need to add anything that we might have forgotten. Boom. So that's a roughshod pricing. May not be 100% reflective. So you're looking at, half the cost per board. So this will just help you get an idea of the impact per board is going to cost you. It's not really going to be this bad. It's going to be in between. That's what I was saying earlier when I was talking about this during the intro and stuff. Parts are not cheap. All right. And I will reiterate, don't spend money that you can't afford. But this is going to be a rough shot. Even though you might have vendor 1B, your price is going to, it's going to hover within the same value between vendors. So I wouldn't worry too much about that. But you could do what if scenarios. You can, so that's per board. You can figure other things out. You can add, your cost of your stencil as an NRE. Really depends on how you want to kind of play this game to kind of understand. We may or may not be spending this much per board to build. But this is at single part quantities, not counting in even the price breaks at like 10 or 20 parts. But, this is just to help you prepare yourself. That's why I do this. Just so I know what I'm walking into. But I did decide to lay out and complicate a board. Now what we can do then is other what ifs. So here are the test points. Now remember, we're paying for each of those. So for low volume, we only get $8 in just those little connectors, those little test points. And I'm rough shotting a $5 board, but we're probably looking about that for low level quantities, because I'm also factoring shipping charges. So yeah, so this is at quantity. All right, enough of that silliness. I just wanted to give you, all the spelling errors it picks up, that's fine. So some other things you might want to do is like, add some entries in here for, you're not being much of a helper, little Henry. Come on, buddy. Maybe when I get my webcam set up, I can show him. Come on, honey. Go on. Go play with your toy mouse. You're putting fur all over my keyboard. So project P101 -01. Let's see. Now, just in case you have to change bomb versions for some reason. So what we can do is kind of merge those cells. Let's flame that all the way over there. Copy. Paste you there. Merge these cells. Oops. Slam you over there. Get rid of there. 1. Put you over there. There we go. I get even fancier. I was like borders. Because if you want to print that out, plus sometimes borders makes it easier to see what you're doing. Format. Unless it's down here with the right click. What is it down here? Borders, yes. Borders, okay. All right, perfect. Format. So this bill of material, this LibreOffice, the spreadsheet will be in, in the project files on GitHub with everything, so you can kind of learn from it, see how it works. So right now, I'm gonna kind of hide columns because you'll see why. Let's kind of open that up. I want you to open up. All right. So we're going to go into Odo and inventory. So products. So we're going to start getting some things going on in here. We're going to split this out into separate inventory items, which will get their own bill of materials for multiple reasons. For one thing, it'll be easier to handle scheduling and routing for SMT versus assembly, where you do through-hole parts, and versus a finished product which you're going to sell. So what we're going to do is we're actually going to create a couple of new things. So let's go in here and let's grab this guy, our PCB text. So we're going to want to do new and just copy that in there. Let's get rid of the version number. We can keep the version number, but that would involve anytime you revise the board, you have to create a whole new entry into the system for that part. Now, it would be great. Maybe that's something we should do. It wouldn't be a bad idea, but the way Odo works, it becomes a pain in the rear. So, it's not a sellable product. We have to purchase it. We will track inventory. There. We're going to assume it's $5. Purchase. Category. So there's nothing here for it. We're going to call it Bare PCB. And the parent category is goods. We're going to save that. Now, we are going to give it a reference. 01. Let's not give it too complicated. Let's stay relevant. So that's the project it's associated with. Bare PCB. FR4 TG 150 to 160. So these are ideally what we're looking for. Green solder mask. white silk screen. Hazel PB, actually it's lowercase, 3. 1.6 millimeter thick. And then kind of, if we want, we can do 120 by 85 millimeters. And then okay. So there, that purchase vendor. GLC PCB, blah, blah, blah. It's a company. We won't worry about any of this. That's fine. We can always update it later if we have to. We'll leave that blank. Oh, boom. Now, something we're going to also want to do. So one of the things I want to cover. So Odo goes by this. So what we can do then, we'll leave this alone. What we can do then is add a we can call it Rev1. So I don't know if that gave us a new circuit board. Bare PCB. No, good. It fixed it. Okay. So that's what we'll do. So Odo uses the internal reference, and you can't have items carry the same internal reference. So this is what we'll do. The right way to do it. So 01 will be its own board. If we have to do a board spin, we'll put O2 and then change this rev. If anything changes, like the solder mask, the PB free, whatever, we'll change it. We'll make sure it matches what it's supposed to be. But Rev 1, as long as we keep that, Odo won't care. So that's bare PCB. Now, something we're going to want to make sure so let's copy this. We're going to create a new product. It's not going to be sellable. So it's not going to be PCB. It's going to be, yes, you should keep track of your stencils. Okay, so it's not sellable. Stencil 01 top. Because a lot of times I get separate stencil for top and bottom. Sometimes you can have them put them both on the same stencil. Sometimes it's easier just to get two separate stencils. It really depends. I think the stencil cost is 15. We'll fix that. There's nothing new here for it, so we're going to create new. We're going to call it PCB stencil. And it's technically a good because you have to pay for it and hold on to it inventory. So, all right. Get rid of this. Top side. And usually I do choose like okay. Electropolishing, so that's going to be for that. And we're going to save that. We're going to create a new product. And I bet so what I did something wrong here. No, what is this? What in the world is that? I'll have to figure that out later here. PCB stencil. So we're going to create a new one. And we're going to bottom. Now, I like to work on multiple tabs. You'll see why here in a minute. Fix this, go to PCB stencils, open the top, copy that, come here, general information, it's purchasable, PCB stencils, reference, and we're going to do bottom side. All right, sale price that, I think it's still 15. PCB stencil purchase. See, no, and we're gonna pop that up. All right. So, stencil top and bottom, bare PCB. This all makes sense if we were able to have Odo with the work order routing capability to create travelers, and then we could add these as like equipment that goes with the building process. But also this is for inventory control, so you know what you have. You can track what you bought, because with business you will have to pay taxes on this type of stuff at the end of the year. When you're when you're at the point of making money above the hobby exemption limit, once you reach above that, you'll have to actually pay tax on these for holding them in inventory for your first year. So that's why you want to actually put them in inventory. Plus, you can assign them a location. So there are other things to note that we can do with inventory. I thought there was a way to actually give it a location. Description, general information. What else are we looking here? Inventory, logistics, which is fine. Description is okay. Where to store the products in the warehouse. So we can put a note here, SMT. Put little notes like that. That's fine. So we're going back to products. So we have bare PCBs, PCB stencils. So we've got that in there, because it's also going to go into our purchase order to order from JLC PCB, the 2 stencils and the bare boards. We will get to that in the next video. So now let's copy this, because we're going to need this one more time. Products. So we're going to create a new PCB. So, and SMT assembly. We don't purchase it. It's something we actually manufacture. We track inventory. So there, like that. Cost, we won't worry about. So search more. Okay, so we don't have that. So we're going to put in SMT level assembly. Or SMT level, assembly. And it's still goods. Save, okay. So we'll go here. We'll kind of look at our PCB. So what we can do then is we can also throw that in the BOM if we really wanted to. There's no description code in here, so I'm not going to worry about it. So let's go back to here. Let's go back to the SMT assembly. All right, Rev 1. Okay. SMT level PCB, revision 1.0. Says we're going with the project number, inventory. So it's something we don't manufacture. I have to figure out why I'm missing that, but so I'm gonna have to figure out why I'm missing so inventory. There used to be an option in the other version, my older version of Odo, for you have sales purchase, but you manufacture the good. So I'm gonna try to figure out what that is, and we'll go through the rest of taking care of this in the next video. But we're already a little over an hour in, and I'm gonna go and call it here. So thanks for watching. Be sure to check us out, and look forward to seeing you in the next video.